Welcome everyone, this is Dr. Myers coming to you from San Diego County, and welcome everyone to BST 322. So tonight what I'm going to do is I'm going to go through the overview of the class, and I'm sure most of you have read the syllabus. My postdoc and my PhD are in physiology, and I've been writing books about statistics. I've had multiple courses in statistics. This class for the nursing program and the health programs are run by the health sciences programs. We don't run this out of the mathematics department. So this is a biomedical statistics program class. And so I'm not a statistician, although I've written books in statistics and I publish a lot in statistics, but I'm going to definitely bend this class towards nursing, medicine, and health sciences. So it's going to be a little different makeup for everyone. I'm going to try to keep this very medically and nursing, health science tainted. So if you're looking for a math class, this is not it, which probably some of you are happy about that. And I know some people have been away from math for a long time and some have been away from statistics for a long time. So in this class, we're going to focus on patient care and evidence-based practice, a little different from what you might see with a class, for example, coming out of Coles or from a mathematics department. This class I've set up in a weekly format, so hopefully you've all navigated to Blackboard, right? And you can see that Blackboard is very left-hand navigated. So for week one, I put a little welcome video for how the class is working, so you can go and view that on YouTube. I use YouTube a lot. I've constructed a lot of videos for this class to help you with the assignments and to do the work. So I'll show you where those are as we go along. And basically for this class, you're going to have weekly assignments. So by Sunday night at midnight, you're going to basically each week do an assignment. So part of that assignment will be doing work in StatCrunch, the software, and you'll have 2 discussion threads to respond to, and people are already posting to the discussion boards. And then you'll have a quiz each week. The last week, you're going to have a final due and the independent project. The quizzes are going to cover the material that I'm covering in the course slides and the textbook. You're not going to be doing problems or StatCrunch work on the quizzes. So the quizzes are just matching multiple choice, true, false. And as I took stats before in medical school, it's open book. So just make sure you have your textbook open and have your notes ready and read through so you're ready to take the quiz each week. So again, I'll go over that as I go through the topics for tonight. The independent project, I'll talk more about next week. That's the last week of the course. And for this week, I'll just focus on the assignments that we're doing now. Again, if you look at week 1 for Blackboard, there's lecture notes. So I did post the Zoom slides for tonight, so you can go ahead and download those if you haven't already to follow along. So these are the link to the discussion threads. And so for the first one, you're going to do some numbers and do some stats on those. And then for the second discussion thread, we're going to work on cross-tabulation tables. So I'm going to go through examples of these tonight, and then you can work on these in the discussion boards. So the discussion boards for this class are a little different. You're not going to share your feelings or post up articles or discuss topics that you might be interested in. We're going to work together in the discussion boards on the stat problems. So I find it very helpful for this course where students are actually, you're working together on these types of examples, which will help you do your assignments. I think for stats, it's often hard when you're doing this new software, StatCrunch, which I'll show you tonight. A lot of people say, oh, I don't know if I got the right answer. I don't know what I'm doing. I can't check it. So the discussion boards, you're going to have 2 problems each week to work on. Once you post the thread, then you can see what others have posted and check your answers. And then people can give you feedback. And I'm on the boards every day, usually 2 or 3 times a day, to give you feedback to see how you're doing on the StatCrunch work. So for this class, you're going to do the 2 postings each week. That's going to give you your points for the discussion board. So you don't have to comment to other students, although you can. Some people are, especially if someone helped you. If you posted up and then someone else you saw per part of it helped you finish the problem, you can just give them a shout out and so forth. But you don't have to respond to each other, but I will be leaving feedback for everyone on the discussion boards. So also in Blackboard, if you're new to it, there's always more than one way to get around Blackboard. So you can get to the discussion threads through the weekly areas. And also if you scroll down, there's a discussion board link. That's called the big board in Blackboard. The big board, that displays all of the threads at once for you. So here's the ones we're working on now. there is the introduction to class, so people are posting there, so it's great to meet everybody there and find out what people are up to. Then there's also the virtual office, so you can leave comments there for the class. I'll respond there as well if it's basically like office hours. If you have a question you think everybody would benefit from, you can post that in the virtual office and I can respond there, or you can email me as well. So there's the discussion board. So again, for week 1, you're going to have the readings are there. So tonight we're working on chapters 1 through 4 in the textbook, and the class slide sets are there, terms to know. There's some activities if you want to practice with those, the discussion threads, and then the assignment. So I'm going to go through examples of your assignment tonight for that one. And the assignment, you basically click on that link and download the Word document. I'll go over that with you tonight, the questions that are there, and then you simply put your answers in the Word document, and then you can post that up and submit it through the assignment area. Then the discussion questions, you can just respond, post a thread, and do the same thing. Just make a Word document, call it week 1, discussion 1 or discussion 2, and then just attach that to your discussion thread. And then we can all see those in Word or PDF. So I went through this on the intro video, but I'll go through more stuff on the class as we go through tonight. I don't want to repeat myself too much, but I'll show you where all the stuff is as we go along. But again, the Blackboard is very left-hand navigated, so you'll find all the stuff here on the left-hand side. And the most important one is this course resources area, and that's down in this area, course resources. And there's the virtual office link is there. The ebook is here as well, so I have it available for you as an online textbook. And again, there's multiple places on Blackboard for the same thing. We have the Dart ebook here on the left-hand side. That's a little fancier. You can navigate through there and download the ebook, or you can click on it here and it's a PDF file. I know some students like the PDF file, so the textbook author gave us the PDF, and then you can put that on your tablet or your smartphone and students can read it from there. So this textbook is Dr. Pulit. She's a great researcher. This is the actual paperback copy. And all in the back is the tables. And I'll show you, I'm going to give you a little shortcut to the tables. I'll show you that tonight. But this is the textbook. But again, you have it in digital form. You don't have to buy it. It's included in the tech fee that you paid for this course. You have the tech fee covers your textbook that you get virtually and the software. So in this class, we're going to use StatCrunch. So there's many statistical software packages. You probably heard of them or used some of them. SAS is a big one. The textbook uses SPSS, right? Social statistics package for social scientists. It's a mouthful to say. That's what the textbook uses. There's also R is another one that's free. And StatCrunch is actually probably the easiest one to use. So in the textbook, in the shell, you go to this area here for the StatCrunch resources, and you can click on the link there to open the StatCrunch. And when you navigate through there, it may ask you to create a private account. You can use your NU email for that, and then you have access to the software. So once you get to StatCrunch, it looks a lot like Excel. It looks a lot like SPSS. And what I've done in the course shell is for every analysis we're going to do in this course, I've created a YouTube channel. That's the instructional video link. And there's one for each one. So bar graph, pie charts, box plots, descriptive statistics. These are the ones we're going to go through tonight, cross tabulation. So you can either look at the recording for this class, because I'm going to go through some more examples, or I've got shorter links here for the YouTube videos. And I've also linked those to the discussion thread. So I've tried to make this course a little easy to follow. Everything you need, the resources are there for you linked in the course shell. So StatCrunch is pretty easy to use. So there's many tutorials available in StatCrunch, and you've got the videos, and I'm going to go through examples with you tonight. It looks a lot like Excel when you open it up, and you can load data into it, you can type into it, and I'll be going through examples of that tonight. But StatCrunch, pretty easy to use, very powerful software, and you can add it to your resume when you're done with the course. So I'll go through some of those with you tonight. So when we're talking about statistics, we're really talking about looking at data and sampling, right? We're going to look at population data. So for this course, biomedical statistics, we're going to spend a lot of time looking at central tendency. So when we deal with patients and we deal with health data, we want to know what the typical value is. So tonight we're going to talk a lot about things you probably heard about before, right? The mean, the average, the mode, statistical stuff that you probably heard you got in math class, or if you took a basic stat course. We're going to talk a lot about central tendency. So some of those you probably already heard about, and I'll show you how to do those in StatCrunch. In this course, we're going to be stuck on a lot of bivariate descriptions. We're going to look a lot in this course at only one and largely two variables. So we're going to correlate variables. We're going to look at patient data. We're going to give patient a certain dose of a drug, measure their cholesterol. So it's always two variables, right? One's going to be the independent variable, one's going to be the dependent variable, which you've probably heard before, and I'll give you some more examples of those tonight as we go along. So this course is very heavy on bivariate data. We're trying to find what's called the typical value so we can compare it to what patients are going to experience. And that's all done in chapter 1. So if you've read through chapter 1 in the textbook, Dr. Palit, she talks a lot at the beginning about the difference of biostatistics is evidence-based practice. And this is very big in nursing as well. So a lot of nurses talk about evidence-based practice, right? So we're using the clinical evidence we have in making patient care decisions. When we talk to patients and we say, this is the treatment, this is the consequences, these are the risks, these are the percentage of patients that do well, these are the percentage of patients that don't do well. We do everything in this realm and as an evidence-based, right? We're going to give people the evidence to figure out what's going on, and that evidence we get from research. So I do research. My research is, I started as an electrophysiologist. My background, as I said, is in physiology, and now I'm looking at equine therapy, horse therapy with PTSD in veterans. So we're recording heart rate variability data, going back to my old school physiology, looking at heart rate and heart rate variation and how that affects veterans with their PTSD and symptoms. So research is something that we do, we carry out systematically to answer questions or solve problems. And the aim of that is to get to evidence-based solution. We want to know how reliable things are, what the magnitude of effects are. If we give a patient a drug, how much it's going to help them, right? How precise our estimates are. And we all need statistics to answer these questions. So I've taught probably the two most unpopular courses. I taught chemistry and biochemistry for many years, and now I'm teaching statistics. Not the most liked courses that students take, but they're very, very focused on what we have for evidence-based, and we can't really get around the idea of what statistics can do for us. So it's a very, very important point that we go through. So what is statistics? Well, statistics is really about collecting and analyzing and organizing data, right? So we want to know and be able to interpret what we're looking at. So tonight's going to be probably the worst part because we're going to go through these things called descriptive statistics. We're going to talk about concepts and variables, and we'll keep going with that. Concepts and variables are the basis of statistics, and you've probably heard of variables before, right? A concept is something that is a characteristic or behavior, and variables are something that can take on a note or a variation. And as I mentioned, we have independent and dependent variables. So I'll give more examples of these as I go along, but the independent variable is the thing that is causing or influencing an outcome, and the dependent variable is always the outcome, right? If we give a drug and we're looking at cholesterol level, that's going to be our outcome, that's our dependent variable. So when we go through these, I'll give you more examples. For example, lung cancer, the independent variable is smoking, right? Some people smoke, some people don't. We know that smoking causes lung cancer, right, in about 50% of the patients that are smokers. So pretty high incidence of cancer for smokers. And the lung cancer that we study, that's the outcome, that's the dependent variable. So the independent variable are usually something like existing characteristics, like the smoking status or their behavior, gender, and so forth. They're created by researchers when we do an intervention. So when I do my research in veterans, I may have a control group that's playing tennis or reading, and then I have an experimental group that is riding horses and learning horsemanship. So the independent variable just happens to be the group they're in, right? The characteristic of what we're looking at. And the research questions are things we're asking about to analyze the data, right? So an example is in hospitalized children, does music reduce stress? We put this out into a research question with both of our variables in it, and then we try to find the answer. So within variables, we're going to have different types of data, and this we have to learn because to put it in the software and make the software do what we want it to analyze, we're going to have to make sure we have our variables done correctly. So variables have different qualities, right? So we can say survived or didn't survive cancer is a type of variable and outcome. Cholesterol, right, has a certain level that we measure. Blood pressure, heart rate, all of these things have different measurements. And they can often be described as discrete or continuous, especially for numbers that we're looking at. So discrete variables are categories with a finite number, right? So patients, you can't have half a patient, you can't have half a bed. So those are discrete variables. They're just ones, 0, 1, 2, 3, and so forth. So you don't get like a 1.2. You can't have 1.2 of a sibling or a patient, right? Continuous variables are something like time, heart rate, something that in theory can assume an infinite number of values between points is something that's continuous. So time is continuous, miles per gallon is continuous, right? Ratios, rates are continuous. They can assume an infinite number of values between points. If you have a patient on a respirator and you're doing tidal volume, could be 15.4, 15.5, right? Those are continuous variables. And they're handled a little bit differently in statistics. So the measurement is also important. It involves assigning the qualities to things of the attribute, and it designates how we get to the quantity. And the measurement levels are going to determine what test we use. So when we get to next week, we're going to get to hypothesis testing, ANOVAs, t-tests, and so forth. So we can only do those kinds of tests with interval ratio data. And nominal and ordinal levels are the lowest type of data. They're just categories. So some of these you've probably heard before. The confusing part is sometimes we use numbers to assign categories. So that can kind of get annoying a little bit. But nominal level is the lowest measurement, right? So survived, didn't survive, right? You're in a category, yes or no. Gender is one, right? Male, female. So they're coded into these arbitrary numbers if they're a number system. So if you code data, you can say 0 for male, 1 for female, or vice versa. It doesn't matter. Here, the numbers don't mean anything because they're just a code or they're signifying a class or a category. So these numbers aren't treated mathematically if they're nominal. The class they're in, you can't really get any numbers out of them other than counts for nominal level data. It's just a category. Ordinals, the next level up. Ordinals a little confusing because you can have a category that has some attribute of order to it. So for example, here's a pain example where you have 1 is no pain, 2 is some, and 3 is a lot. They have a little more measurement than just the category, but the numbers don't mean anything, right? When we categorize them like this in an ordinal way. Because you can't use averages, the distances aren't equal, right? A lot of pain and some pain is just too broad. So anything that's ordinal is just a ranking, right? Like you'd have freshman, sophomore, junior, senior, but you can't say that a sophomore is twice as smart as a freshman. They're just categories, but they're ordered, right? So sophomore is farther along than a freshman, and a junior is farther along than a sophomore. So ordinal measurement is an ordering on an attribute, but it doesn't really have, it has an amount a little bit, but the distance between the values is not indicated. So most of the values we deal with are interval ratio measurements, and we combine these together because they're very closely assigned together. So an interval measurement is where the distance between the values are now assumed to be equal. So something like temperature, right? If it's 10 degrees hotter when it's 60 degrees, it's the same thing as to say it's 10 degrees hotter when it's 80, right? 80 to 90 degrees. So the difference between the degrees is the same. So the values are assumed to be equal. That's an interval measurement. So if someone has a cholesterol level of 100 and someone has a cholesterol level of 200, we can say that they're exactly double, right? So the numbers really have meaning, and the values in between are assumed to be equal. And we'll do more examples of these as we go along and put some stuff into the software. We do some examples. So ratio measurement is just like interval measurement. It's just that there's a real rational zero. So a number of milligram, number of pills someone takes, or cigarettes that they take when they're quitting. We're doing a study on smoking cessation. So anything that has a meaningful zero is a ratio measurement. So temperature would be a ratio measurement if we had absolute, like Kelvin, right? Because absolute zero really means something. Zero, if you remember from physics, and Kelvin is all motion ceases, right? So Kelvin has a real meaningful zero. Fahrenheit, not so much, because zero doesn't, right? It's 32 degrees is freezing and zero just happens to be zero. So ratio measurements have to have a real rational zero, where the zero actually means something. And we often combine interval ratio because they all have, the distances are equal, right? So they're very similar in the way they're measured. And ratio just has a meaningful zero. It makes more sense if you look at this slide. So nominal level data is the lowest. So it's, as I said, it's just a classification, right? It's just a category. Ordinal has a bit of magnitude to it, but it's really still a category that's just ordered. And then an interval measurement has all of them, right? It has a classification, a magnitude, and equal interval. And then, as I said, ratio just has a true zero. So you can do more math with each one. And you can go back this way, you can't go back that way. So you can make a rational variable into a nominal level variable. So for, say, we're doing a cholesterol study and we say someone has high cholesterol, which is usually over 200, right? We can say these patients, 20 patients have cholesterol above 200 and 10 patients have cholesterol below 200, low cholesterol, high cholesterol. That's a classification, that's nominal level variables. And then we're just counting the number. You can go this way, but you can't go the other way, to the right. In this descriptive statistics that we're starting with now, basically we describe and summarize the data about the sample. So when we look at all our data, we need to do descriptive statistics, because when we get to next week, when we're going to do hypothesis testing and actually do some analysis, we've got to describe our data. So our percent of gender in the sample, average weight of participants, we're going to use these things to understand our data set. In chapter 1, if you read through that, it's really learning about the levels of measurement. So as I go through some examples, hopefully those will become clearer to you. So in chapter 2, Dr. Pali talks about, and this is the second part of our talk tonight, is frequency distributions and looking at the data and how the data is organized. So the frequency distribution is a way of arranging the data values and counting how many times each one's occurred in the data set. So you basically you can count up each data point, right, and count how many 2s or 3s you have. If you have pulse rate, how many people have the certain pulse rate, and you get an idea of the frequency of each value. So you get something called absolute frequencies, which is the counts of each one. Relative frequencies is the percentages. Cumulative relative frequencies is the percentage for each given score combined with everything before it. So it's a bit of math, but we can get the software to do it for us pretty easily. So any level of measurement you can do a frequency distribution with, but for our categorical variables, our nominal level, we don't do the cumulative frequencies because they really have no meaning, right? Because they're just counts. So there's no order to the data. So for example, if this is one from the textbook, if you put the weights down, so this is the subject weights, you can see the 2 subjects had a weight of 105, 2 subjects had a weight of 102. It gives you a distribution. So as you get a larger data set, can get a little bit unwieldy, so then you want to group it. And the software will actually do this for us. So we can do group the data in groups of 2, 4, 10, 50, depending on what the data set looks like. So if you have a wide range, like for weight here, that goes from 75 to 300, you can group them and count the frequencies in each group. So those are the basic ways we do frequency distributions. So let's go ahead and do something. Let's open up StatCrunch. And again, as you watch this recording later, you can catch up with me, or you can try it now if you've got the data open. Using the discussion 1, question 2 data, so if I go there, we can download it. And some people are already posting up for this discussion question. But if we want to do a distribution, we just click on this file and we'll download it. And for the discussion thread, you're going to do a cross-tabulation table, which we'll get to in just a bit. Move this one over. So here's the week 1 discussion question 2 data. So in the discussion threads, we're working with this data set. So this is an Excel file, and StatCrunch and many programs can easily take Excel files. So if you look, open it up. If you go down to the bottom, you can see, let me make this a little larger. You can see I put the key here on the tabs at the bottom. So you can, in Excel, hopefully you're pretty used to Excel, but if you go down to here, here's the data on this tab, and then I have a little key here for the rest, because some of this is easy to figure out, right? So marital status, that's pretty easy. Here's the ID number of the patient, the subject, and a lot of this data Dr. Palit has given us from studies she's done in Pennsylvania. Marital status is pretty easy. Poverty, again, this is nominal level variable, right? This is just a classification above or below poverty. Marital status is also just a category, right? You're either divorced, never married, which is single, or married. Work now is also categorical. It's nominal level, right? Because it's just yes or no's. And we could put 1s and 2s in here for yes or no's, right? 2 could be no, 1 could be yes, but that's either way, it's a nominal level variable. But here's the CESD score. When you click on the key here, that's the Center for Epidemiological Studies depression score. And it goes from 0 to 60, the higher score is greater depression. And then the mental health score also goes from 0 to 60, with a high score being a positive mental state. So in many of the data sets, you'll see I've made a little key here on one of the tabs for you, because some of the categories are not too clear, although you can probably know what a mental health score is. So for this one, let's examine the distribution of mental health scores. And I think for the assignment, you're going to do the depression score. So let's do the mental health score as an example. So first thing we want to do, we'll go back to StatCrunch. And there's many ways we can put data into StatCrunch. We can copy and paste data just like we do in Excel, or we can type it in, but I don't think you want to watch me type in 150 numbers, right? So we can load that Excel file once we've downloaded it. So I click on the data tab, load from file on my computer. And the only difference from the videos I did last year is they've updated StatCrunch to drop and drag, so you don't have to go find it. It's a little easier. So, but I haven't redone the videos yet, but drop and drag you can pretty much figure out pretty easily. So I think I've got that file, I downloaded it, and I can just drop and drag it over. And how easy is that? It by default leaves the first line as the column name, so I click upload, and it takes that Excel file and puts it right into StatCrunch. So there we go. Looks just like Excel. So now that we have it there, we can go through and we can do the percentage for this one. So to do that, we can click on the Stat tab, and we can click on Tables and Frequency. So that'll give us our frequency table. And then the software is not smart, you're smart. You have to choose the right variable. So we're going to look at the mental health score. So I'm going to scroll down here in this dialog box, click mental health. And the frequency, relative frequency is clicked. I can hit my control key. I'm on a PC, and I can select these. Percent of total, cumulative frequency. And we can do cumulative because we've got interval ratio data. So we can do cumulative frequency. We can do cumulative relative frequency if we want as well. And then we click compute. And what it does is it says, well, it's a lot of data. Do you want to bin it? So here the software is pretty smart. It's going to bin that data for us. So just like we saw in the example in the textbook, it's going to bin the data. And here it is here. So you see that the mental health score is 0 to 10. We've got the counts. There's 58 scores. We're between 0 and 10. And there's the scores, 58, right? Then the next one is 73. So it's doing all the math for us, right? If you take a calculator, 73 plus 58, I've got my handy dander TI-30X. Yes, I am a nerd. And you get 131. So it's doing all the math for us, right? Then 108, it's adding them up as it goes. And it's calculating the cumulative frequencies as well. If you notice, we've got a lot of sig figs, significant figures. So if you took chemistry, I taught chemistry, as I said, for many years. Significant figures, right, are these non-zero figures that are dragging past or below around the 0 point. This is a lot, right? But this isn't a math course, but we can go ahead and edit those under the edit menu. And we can go to display precision if we want to cut those down a little bit. So again, I just go back to the edit menu, display precision, and it's defaulted at 8. I wish it was defaulted at 4, but we can go down to 4. Click compute, that'll load it in. And then if we want to change this, you don't have to go through and do the whole thing again by going to the stat tab and the table tab. You just click options and click edit, and then click compute, and it'll change it for you. So there, it does it to 4 significant figures. So it makes it a little, easier to handle. And again, you can take this and you can copy and paste this into your Word document, right into your assignment or anything that you're working on, any report. So this one's a frequency table, and we'll do crosstab in just a bit when we get to that one. That's in chapter 4. So there's our table there for frequency. I mean, that's as exciting as frequency tables get. I don't know what to tell you. What does it show you? Well, we've got most of our values occurring at 50 to 60. So we've got a lot of frequencies there. If we look at the percent of total, yeah, that's 27%. So a lot of our values are falling into this range. Pretty good mental health, I guess. This is going up to the higher ones. So this one's pretty good. So again, we can report those as a text. We can do the table, and then we can also we can graph it. So for graphing, for nominal level data, we're going to use a bar graph. So bar graphs and histograms are often confused, and bar graphs are for nominal level data. So if we want to graph this, you can already tell it's going to have a peak here around 50 or so. But let me close this one. But even though I closed it, I can go back and grab it again over here by clicking on the StatCrunch tab. You see that little 1 there. But let's go and graph this one. So the software is not smart. I don't like the word to use stupid, but the software is stupid, you're not. You have to tell it what to do correctly. So if it's nominal level data, you click the bar plot, and if you have the data, you click with data. And then you can just select the column. And notice that when I go into this one, we can do a bar graph with nominal level data, and we can do histograms with our interval ratio data. So let's start with some bar graphs first. So we're going to switch back to understanding the bar graph. So the bar graph, again, is for nominal level data, and it's nominal because it's going to be these types of variables for bar graphs. So either you're working or not, either you're above or below poverty, you're fitting in a category, those are done in bar graphs. And that's an example here for marriage status. So we can do that on this one. We can do marriage status. for our example, but bar graphs are done where you have nominal level data, right? So you are either married or single, you're not both. And notice that there's a gap between the bars. That's a bar graph, right? So a histogram is where you have interval ratio data where you're doing counts, and there's no difference between the bars because it's just contiguous, right? You've got an interval ratio variable that's going on. So in a bar graph, though, they don't touch because it's just categories. So pie charts are another way to do it. I'm not a big fan of pie charts, but a lot of business people use them, for example. But for health data, we tend to use more bar plots than pie charts. And pie charts are just the same way, married, single, divorced. It tells you in a different way, more graphical way of your, again, nominal level variable. You're going to be one or the other. It's not continuous, right? You're going to be one slice of the pie or the other. So let's look at poverty with the same data set and create a plot of that. So again, for this one, for bar plot, we would go to our graph tab, click on the bar plot with data because we have all of the data there in our spreadsheet. And again, we're going to be smart. We're going to select poverty and click compute. It's that simple. So by default, I'll go back to that box. We select the variable for the bar plot, and we're going to use the split bars, frequency, and you can change these around, but by default, it's just a frequency bar plot. And you click compute, and it's that easy. And so it automatically labels the x-axis. So here's your above and below poverty. So, well, this is exciting, right? If we drag over, it gives you the exact number. So most of our sample here is a very poor part of Philadelphia. Most of our sample are in poverty. They're below poverty. So that's a real easy way. Bar plots are real easy to do in StatCrunch. We can do a pie chart. That's the second one. Again, with data. We'll select poverty, click compute, and we've got our pie chart. So both are the same ways, but again, bar plots and pie charts are for nominal level variables. If you try to make one with a histogram or some other plot, it'll do it, but make sure that you go back to looking at the textbook to make sure you've got the right looking plot when you do your plots. So pie charts, bar plots are for nominal level characterizations, right? They're just a category. And for interval ratio, it is looks like a bar graph, but the bars touch one another because it arranges the values, the distribution from highest to low, from lowest to highest, shows you the frequency or percentage on the y-axis. But it's contiguous data. So 57, 58, 59, 60, right? These are together because you could have 59.1 or 59.2. So all these values are running together. This is a histogram. Again, one that we do with interval ratio level data. And with histograms, we can look at the shape of the data. So you've probably all heard of the normal curve. We'll talk about that in just a bit, but we like to see data be in a normal curve, and we'll talk about more of that next week when we do testing, because we need normal curves for testing. But lots of data is not normally distributed, right? So here it looks like our blood pressure is peaking at around 65 or about 66, right? But we've got some trailing off here below, some people with a low pulse rate and some with higher. So when we describe those shapes, and again, this is histogram interval ratio data, it's going to be described in terms of modality, symmetry, and kurtosis. And these are big words, which we'll go through, but actually the software will tell this for us as well. So the modality just tells you how many peaks you have. So in that example, we have just one peak. And it can be unimodal, bimodal, or multimodal, depending on what you have, right? So if you have two peaks, it'll be bimodal. Unimodal data just has one peak. The symmetry talks about the distribution. If we look at the data in half, that tells us the symmetry. So if it looks the same, that's very symmetrical. If it's not, then it's not symmetrical, or what we call skewed or asymmetrical. And that's with peaks that are off center. So you can have a couple different ways those will look. You can have positive skew or negative skew. And the software will actually tell us the numbers for these, which I'll show you in just a bit. So the positive skew is when it starts trailing off to the right, and the negative skew is when it starts to trail off to the left. You've got some low numbers that are trailing off to the left side. And again, there's a skewness index, which StatCrunch can print out for us. Negative values are negative skew, positive values, positive skew. And if it's close to 0, that's no skew. And then as a guide, if the skewness is about less than twice the value of the standard error, the distribution can be treated as not skewed. And we'll talk about standard error more next week when we get into more advanced hypothesis testing. So for right now, we'll just look at the negative and positive skew. So here's an example here. There's a positive skew because you see the numbers are skewing off to the right, to the positive direction. And here's a negative skew. These are examples from the textbook where the numbers are going off to the left side. And Taylor's asking, in regard to shape, what does the index refer to? So the index is just a calculation of the skew. So if it's positive, it's just calculating which direction the skew is going in. So the positive is a positive skew, and then the negative index is a negative skew. So kurtosis is the pointiness or the peakedness of the data. And if it's very sharp, it's leptokurtic. If it's flat, it's platykurtic. And if it's nothing, if it looks like there's no peak, it's mesokurtic. Just like for the skewness, the index, the positive value is more peaked, negative value is more flat. So again, it's just calculating based upon an index of if it's positive, it's going to be more peaked, the values are peaking. If they're flattening out to this direction, you get a negative index. And these are calculated by the software. So the normal distribution is called the normal curve. You probably heard about that. If we're in psychology, they don't like the word normal, but the statisticians don't mind it. It's bell curved, often called a Gaussian distribution. It's unimodal, it's symmetrical, it's neither peaked nor flat. And when we get to next week where we do inferential statistics, hypothesis testing, we'll talk more about it. But it looks like this. So there's a lot of things that have a normal curve. So IQ is one, right? So typically IQ is around 100. There's a bunch of people, all of us are kind of around the same IQ. There's a few of us that are smart, right, that are on this side, and some are not so smart on this side. So IQ is an example. This one is just an example of people. If you have one tall person, one short person, and 3 medium people, you're going to get a normal curve. Again, they got one tall person, one short person, and most of the people are in the middle, gives you this type of normal curve. Looking at this distribution gives you a feel for the data. Is it skewed? Is it normal looking? Is it flat? Is it not flat? So you can figure out from that, did someone type in the wrong number? Is there some outliers? And so forth. We'll talk about those too tonight as we go along. So outliers are things outside the normal range of values. They may or may not be legitimate. We have a strict definition about outliers, which we'll get to and very quickly. And some things are wild codes. If someone's coding the data, they may have put in the wrong number. Like if we had a depression score of 180, that would probably be typed in wrong. So you want to look at the distribution of the data to make sure that the data is okay. And it tells you basic stuff about the sample. So what percentage have a certain gender, what percentage have an ethnicity, what their education level will tell you about your data that you can make conclusions about. So these are all descriptive stuff that we can answer. And again, this is kind of the boring part of the course, but next week we can then take these numbers and do some inferential statistics. We can look at hypothesis testing, like does taking a drug really stop a disease? Does taking a drug really lower cholesterol? And that's all based on hypothesis testing, which we'll cover next week. So these are the basic steps for the histogram. So we did these already tonight. So again, you go for frequency distribution, you click on the tables, and under the stat tab, you click on tables and go to frequency. And you can then, for the histogram, you click on the graphics tab and histogram, and then you can get the graph displayed that way. And again, like we did, you can hit the edit button if you want to change the font and so forth. And so let's see, let's do another example. So if we have creatinine phosphatase, can we look at the distribution? Can we make a histogram? Is the distribution skewed? And what does the kurtosis look like? So let me open up another tab here for StatCrunch. And, oh, we got a lot of numbers. Let me go through this one. I'll escape out of here. So if you got a bunch of numbers and you don't want to watch somebody type them, you can just drag over them. Does everybody know the word trick to get things into StatCrunch? So if I copy and paste this, it does that, which is disappointing. You can fix that by using the trick in Word, just the replace function in Word, and fix it. So if I copy and paste those numbers in, and make this a little larger, I've got all these commas, right? So if I drag over that, you can just use the replace function under edit, and we can just replace those with a hard return or a paragraph mark. I can just take that comma and the space, I'll just copy that to find it, and then I go to replace with, and you go to more, special, and you can Google this if you get lost, or you can watch the recording. You just put a paragraph mark there. You can just Google how to replace stuff in Word, and it'll find it. But again, I just found that thing where the comma is, hit that, then I hit replace all. And now I've got everything in a straight line, and I can just copy and paste that into StatCrunch. 36 volunteers, so I should have 36. Now when I go back to StatCrunch, I just paste. Ta-da! Or you could watch me type in 36 numbers. Looks like I got them all in there. Okay, and you can do this on your homework too, or the discussion threads. Just use that trick in Word. So you're getting your money's worth. Tips and tricks for Word. Okay, so we have the data in there. And again, you can work on this to make sure you can do the what I'm doing here to create the distribution and histogram. So the frequency distribution table, we do the same way, right? We go to the stat tab and tables, frequency. And I guess I plopped it under variable too, so I'll click that one. I can click my formatting that I want. I can do cumulative here because I've got interval ratio data, right? So we can do the accumulation of the frequencies as they go. Click compute, and again, it's going to tell me, oh, it's going to bin. So we'll click OK because we've got a lot of range here, 42 up to 100 and something. So there's our table. Again, 36, we want to check that. And we can see most of our values for the creatinine phosphokinase are around 50 to 30. And there's our cumulative frequency. Again, if this bugs me, I have control issues. So I'm going to fix that. And then I can edit it and click compute again to get them to 4. There we go. It's not necessarily wrong to put it out to 8 digits, but it's just a little, it annoys me. So it looks a little cleaner this way. So now we have our frequency table and our histogram we can look at to see if we have skewness. So again, I click graph. I'm not going to do bar plot because I've got interval ratio data. I'm going to click histogram, select my variable, and click compute. And there we go. You can change the binning as well. So if I go back and edit it, it's binning it. Let's see, what is it binning it at? Like 25? Yeah, 75. So it's probably okay. But you can change the bins if you want it to look different. You can make the bin width, let's try 10. And it just looks a little different. I don't know if I like that anymore as well. But it looks like it's got one peak here. It could be bimodal, but looks like it's one peak around 90 or so. Let's take that out and leave it back the way it was. Kind of has one peak here and it kind of goes off to the right. So the first is, go ahead and type in A, B, or C. Looking at the skewness, is this one positively skewed, negatively skewed, or no skew? A, B, or C for this one.
Negatively.
It's one choice. We got some B's and some A's. So negatively would skew this way, right? So it looks like it's going this way. And so how do we check our answer? We can go to the Stat tab and click on the Summary Stats. Select our column, and if you scroll down, you'll find at the bottom is the skewness. And there it's positive, 0.8. So this one's positive. It's kind of hard to see, I guess, but it does kind of skew to the right, right? Since data's going down, is it positive? So, it's going down, but it's kind of going up because these are the higher values. So these are, even though they're lower, they're higher, and they're skewing our data to the right. It's skewing it positive. And if you get confused, this is what I do. Just let the computer tell you the answer. You can, again, go to the Summary Statistics, and you can get the data by clicking on the column. And then you can select, just scroll the box down here, and get to skewness. Kurtosis the same way. So this one is positive. So again, we can verify that by looking at the Summary Statistics tab in StatCrunch. So that one's positively skewed. For the kurtosis, try again. Is it A, B, or C here? Is this one platykurtic, the peaked, leptokurtic, or no kurtosis? Or platykurtic is the flatter one, right? Which we went over up here. So platykurtic is the one where it's flat. Leptokurtic is the one where it's peaked. So you're already typing. Yeah, this one looks peaked to me. So it's leptokurtic. And again, if we can test that by going, we can just click the options here. We can edit this one, and then we can use our control key to select the kurtosis, and it'll tell us everything. And it's positive, so it's leptokurtic. Okay, we got that one. So StatCrunch, pretty easy. I mean, once you get the hang of it, it's pretty powerful, actually. It makes nice graphs. You can, again, copy and paste these into your reports and your assignments or whatever you're working on, and then you've got your data at your fingertips. So this one's leptokurtic. So let's try with this one. So recent drug and behavior combo to look at days until cessation of smoking. Looks like some people quit right away. Let me look at this one. And do a frequency distribution for this one. So let's just grab a new tab here. Two, 9, 2, 8, 9. Again, you can follow along at home and practice these, or go back to the recording later to make sure you can practice and do all these. Hopefully I didn't make a mistake. 7, 13, 9, and 0. Or I could have pulled that into Word and copied it. 26. Oh, did I miss one? 5, 7, 13, 9, 0. Guess I should use the Word doc. I can't count. So 26 subject. Let's just use this data and see if we can get the histogram. So again, the frequency distribution table. We go to the tables, frequency, select that variable, hold down the control key and select those. Cumulative frequency, yes, because this is interval ratio data. Click compute. And this one didn't group it, right? Because it's only varying from 0 to 13, so we didn't group this one. And we can see most people took about what? About a week, about 6 days, or about 9 days, right, to get to cessation. And again, this would bug me. I'll go back and change this to 4, but I won't do that because I don't want to bore us any more than we already are. But we can switch those if we want. And let's go ahead and do the histogram. Again, graph, right? Histogram, variable 1, click compute. Again, it didn't group it. It's just going to plot it. This one's got a peak, right? Where we saw it was going to be. This one looks really off. So for this one, is this one going to be positive or negative skew? You can just type in positive or negative or open your mics. And then we can go and look at the answer on the summary stats. Yeah, I think it's going to be negative because it's skewed off to the left. We can just scroll down there. Got a lot of stuff in the summary stats. There's skewness. Oh, I didn't select it. See, the software is smart. Okay. Yeah, negative. So that one's negative skew because it's going off to the lower values here, off to the left. And the kurtosis, yeah, this one looks peaked, right? So it should be leptokurtic. Oh, we just click option, we can get the answer for that one. And we'll hit my control key and get the kurtosis. That should be positive. Oop, this one's negative. So I guess it's more flat. This one's real flat because it's getting, looks like it has a peak, but there's a lot of values making this one flatter. Yeah, I guess so, even with this peak. So the software won't lie to us. It'll tell us we've got, this one's rather non-peaked. So it looks like our sample, some people were doing well the first week, and then we got some here, and then it kind of tapered off. So let's do, that's when we typed in. So again, you can type in data. So let's go back to this one again. Let's look at mental health scores. So we did the distribution for that one. Did we? I thought we already did that one. There's our data. I think we just did the plot for that one. Oh, we just did the poverty for that one. So if we go back to that data, that's the one we're working on for the crosstabs table. Yeah, we did that one, poverty. And if we just go to the graph, we can make a histogram of those mental health scores by just clicking on them. So this one looks also skewed to the left. Yeah, I think we did the frequency and the histogram. We did frequency table for this one. Oh, it's down here at the bottom. Yeah, I think we did poverty for that one. This one I grouped as well. Okay, we did that one. All right, well, I think we've done the histograms and bar graphs. That's as exciting as displaying data gets. So the next part is our variability, relative standing, and central tendency. Now that we've got all this ability to do these descriptive statistics in StatCrunch, we can look at some things of the data as far as we can describe the data descriptively, like we can have the peakness, right? We can figure out the histograms, the bar graphs, the frequency tables, but there's also actual data we can get from this one, right? So we want to look at indices or numbers even more detailed than our skewness and kurtosis, right? So these are measures of central tendency, and some of these you probably have heard about before. So we can move through some of these, but again, this is recorded, so if I go too fast, you can slow it down later. But these things you've probably heard of before, right? The average, the mean, the mode, the median. So the mode, I always think is the mode is the most, right? MO, and it's the most popular score. The one that occurs the most is going to be the mode. And that's how you describe the data. Easy to compute because you just look up on the frequency, right? If you're doing the counts, you can figure out which one is the mode. It's the one that occurs the most. It's an actual value in the distribution, so you can understand it that way. It has its disadvantages. It can be unstable. It can vary sample to sample. Some things don't have a mode, right? If they're all the same frequency, they don't have a mode. Sometimes you run the data set and you don't get a mode. The median, a lot of people like the median. It's a score that divides the distribution into two halves, so 50% are above, 50% are below, right? So you've probably heard of the median before. It's that value occurring right in the middle. And again, our software can calculate these as well. The median's not influenced by outliers as easily. It's a good index of what's typical when you see a data that's skewed. It's easy to compute, right? It's right in the middle. And you can also use it when the data are ordinal. So you can take the ranks and find the median ordinal measurement in your categories. It has disadvantages, right? It's not necessarily an actual value, because sometimes the median, you've half and half, you have to take the two middle scores and divide them by 2. So it's not actually an actual part of the data set. It doesn't tell you much. It's an index of position. The average is the one we use a lot, right? So the average is you just take up the numbers, you put them in your calculator and divide by n, right? So the mean is exactly a mathematical equivalent of just taking the numbers up and dividing them by n. And so we use this one a lot in statistics because it has a lot of advantages, right? So it can tell us a lot about the data set. So it's the balance point, right? It's the sum of the deviations above the mean is always equal to the balance of those below it, right? Doesn't ignore any information. So the average takes in everything from the data set we have. So therefore, it's the most stable index. And again, we're going to use the mean. You're going to be so sick of the mean by next week. We use that a lot in hypothesis testing, the average or the mean. It's not without its distractions. So it's sensitive to outliers. It can be a distorted view of what's typical when the data has a lot of skewness, because it's taking in all of the numbers. And the average is, it's not an actual data value, so that bugs people. And just to make you even more bugged, in statistics, we have an entire language of stuff. So in statistics, the mean symbolizes M, but it's also in formulas can be called X bar, the X with the bar over it, is the mean or the average. And population means are the Greek letter mu. So when we talk about populations next week, we'll be using that configuration as well. In a normal distribution, all three of those line up, right? They're completely symmetrical, the mean, the median, and the mode in a normal distribution. And once you start getting any type of skewness, so with a negative skew, that's going to pull the mean to the left. And with positive skew, it's going to pull the mean to the right, right? Because you've got more values at a higher level. So the mean will pull with the data set because it's taking in all of the numbers that are there. So variability is another thing we look at in descriptive statistics. And two distributions can have the same average, right? But they can have a different dispersion. So variability is something you've heard of, right? Probably standard deviation is what people have heard about. When there's a lot of variability in the data, it can be very wide, right? The range will get quite wide. And then if it's not a lot of variation around the average, it'll be a lot less. So variability, we talk about range, the interquartile range, standard deviation, and the variance. So probably some of these you haven't heard of before, and some of them are going to have to calculate. So the range of data is probably easiest, right? That's the range of the values. So for the textbook example that's in chapter 3, the range goes from 110 to 190 for the weights that we're looking at. So the range is 80, goes from the lowest value to highest value, right? So range is easy to compute. You can understand it. If you talk to someone what the range of the value is, they could probably tell you what that is. And it gives information that readers can understand and report. It has disadvantages too, right? It's sensitive to outliers. So if there's a big outlier, it's going to make the range quite large. Only depends on 2 scores and gets influenced by sample size and tends to be very unstable. So the IQR is probably the most weird one to think about. It's the interquartile range. So if you stop someone on the street and ask them what the IQR was, they probably couldn't tell you, right? It's a little more mathematical. So the IQR is the Q3 minus Q1. So Q1 is the lower quartile. So you have to take the data set, drop it into quarters, right? 25%, 25%, 25%, 25%. Q1 is the points below 25%. Q3 is the points below which 75% of the data lie. So the interquartile range is that middle part where 50% of the scores lie. So if you stop someone in the street, they probably couldn't tell you that. So the IQR is a little difficult to compute. So again, the IQR, you have to add these up and figure out where the quartiles are and calculate the IQR. But again, the software is going to do this for us. We don't really have to do it by hand. The advantage of the IQR is it gives us more information than the range, right? It's telling us where 50% of the data lies in our sample. It reduces the influence of outliers and extreme numbers, and we can evaluate outliers with it. So when you say, oh, looks like something in the data, like if we look at the distribution, oh, this is an outlier. Well, you can say that because it looks like it's outlying, but in statistics, we have a definition for an outlier. So it has disadvantages, right? It's not easy to compute, so we're going to make the software calculate it. It's not well understood, right? Normal people don't talk in that language. And it doesn't take all the values into account. It's only looking at the 50% in the middle. The one that you probably heard about is the standard deviation, although it's harder to compute. So it tells us on average how the scores in a distribution vary, and it's depending upon the average or the mean, right? So when you look at the standard deviation, you're looking at the average. So what you have to do is you have to get the average, and then you do all the math of figuring out how much each value deviates from the average, and then you take all of that, and then you take the square root of all those divided by n-1. So if you look in chapter 3 where that is at, I think it's on page 46 actually. So it has a little bit of calculation to it. If I open up the textbook here, this one's on page 46. Zooming by it here. There's the formula for standard deviation. So again, not too intuitive. So you have to sum up all of these things, all the x values that you found, square them, divide them by n-1, and take the square root. So it's a little bit difficult to compute. So again, we're going to have the software compute this for us. But it basically tells us how much the values differ from the average. So again, it's a lot of math. You take this deviation scores, then you square them, then you sum them up, and then you divide them by n-1, and you get your standard deviation value. So again, it tells us on average, the amount of deviation scores vary from the mean. So it tells you on average how wrong the mean is as a summary of the overall distribution. And it gives us information about the data set. So what we know mathematically is that with everything in the data set lies approximately 3 standard deviations from above or below the mean in normal distribution. So if you have a normal distribution, 3 standard deviations is going to contain like 98% of the data. So the farther we get from the mean, there's 1 standard deviation, there's 2 standard deviations, and there's 3 standard deviations. And what it helps us do is if we move sample to sample or group to group, like if I'm measuring my heart rate in one group of veterans, then I have another the next month, I can take the average and then create the standard deviation, and then I can compare the groups that way. So again, someone with a score 1 standard deviation below the mean has a higher score than 16% of the cases. So depending on which one you look at, you can have different percentages away from the mean. So it has advantages. It again tells us all the data, has all the data. It's more stable than the IQR. It lends itself to computation of other measures. So we're going to use this standard deviation next week and other statistics we're going to calculate. And it helps interpret individual scores when the data is approximately normal. It has disadvantages as well. It's influenced by extreme values. It's not intuitive. So if you stop someone in the street and ask them to explain standard deviation to you, they probably couldn't do it. It's quite a formula that they have to sum up all these deviations, square them, divide by n-1, and take the square root. So that's standard deviation. The variance is just the standard deviation squared. So you just take the standard deviation, which is the square root, you square it, and you get the variance. So when we go back and look at these, we can only do those types of calculations for our higher level measurements, the interval ratio. So interval ratio, you have a mean and you have all the ones above it, right? The median and the mode, the range, IQR, standard deviation, and variance is all can be done with interval ratio data. Ordinal level data, the ones that have the categories that are ranked, can have a range, IQR, and a median, and then the nominal level variables can just have the mode. So just like we saw before with the math, the most math you can do with, you can only calculate a mean or an average with interval ratio data. You can't do it with ordinal and nominal level data. So outliers are actually defined by a formal definition in statistics. So when you call something an outlier, you have to calculate it. So a mild outlier is something that's 1.5 to 3 times the value of IQR above or below Q1 and Q3, and an extreme outlier is 3 times the value. So to do that, we look at something called a box plot. So there's our box plot. So box plots are just a strange way of looking at our data as well, but it tells us the quartiles and it tells us whether we have outliers or not. We call them box plots or box and whiskers plots, and through them you can see the quartiles. So for example, the bottom of the box, this is Q1, this is the median, and this is Q3, and then the whiskers are the limits of what's not an outlier. So once we see values occurring past the whiskers, those are outliers. So to call something an outlier in stats, you have to actually calculate the IQR and see how far away you are from that. So again, here's the example that Dr. Polite does in the textbook. So you calculate the median. Here's the median at 66. Here's Q1 at 62. And here's Q3 at 68. And if she added the other values that are here, anything beyond the whiskers is an outlier. So anything that's inside of it is not an outlier. So again, box plots are a little different. So here's the original data before she added the outliers. You can see there's our 55. It looks just like the histogram, right? There's 55. The median's about 66, so it's look like that's where our median value is. 74, there's our top range. So the whiskers are the range of the data, and they're the range of the data that don't contain any outliers. So this initial set, there's no outliers in this set. There's no values beyond the whiskers. So the outliers, you can see them you can kind of see them in histograms. So when you add these out values, you kind of see them, but again, you have to do a box plot to actually calculate them to see which ones are the outliers. The box plots are something that brings us called the standard score or the z-scores. That's another index, and I'll go through some of these examples in just a bit. We can do some calculations with these. The standard score is also called the z-score. It's expressed in standard units, how things are distanced from the mean. So that one is in page 51, right at the end of chapter 3, or page 50 rather. So we have the standard deviation and the standard score. Again, that's in chapter 3. Next page, make this a little smaller. So here's our z-score. So again, when we're doing standard scores, we're taking the value minus the x-bar, which is the average, the mean, and we divide by the standard deviation. That gives us our z-score. So it's a standard score. If it's positive, right, that's going to tell us that it's above the mean. If it's negative, that tells us that we're below the mean for that value. And again, the reason we do the standard score is it'll tell us how things deviate from the average, and that will be used sample to sample. So once we calculate our average, we can convert everything to standard scores, then we know how things vary group to group in our samples. Again, these are all stuff with descriptive statistics. I'll try to go through some examples here. So it gives us the big picture of what the data looks like. It gives us a number for trying to figure things out. And it helps us evaluate the outliers in a way that is statistically relevant. So the outliers are going to be the values that are 1.5 or more times IQR away from Q1 and Q3. And we can see that in the data. So if we go back, if you're still awake, go back and look at this data set. We can actually do this one. So we've got those numbers for the creatinine phosphatase example. Here we go. So we graphed that. These are all the numbers. So we did the distribution for this one. So how do we get the mean, the median, and the mode is pretty easy, and the box plot. So for the mean, the median, the mode, the variance, the range, rather than calculate it, we can go to the summary stat button, columns, select our variable 2, and now like I was going after the skewness and kurtosis, there's the mode. I can use my control key on my PC. I can get the mean, the variance, standard deviation, standard error we'll talk about next week, median, the range. We can get all of the stuff. We can even do Q1 and Q3. Click compute and it'll print the values for us. So there's our range, our median, there's the average, the X bar, 98.28, the variance, standard deviation. So it did all those calculations for us. And we can do a box plot just by clicking the graph tab. So we did bar plots, we did pie charts, histograms, keep on going to box plot. Again, we'll select that variable. We can put in the median and the mode if we want to, or the median and the mean. We leave that by default. The fence is to identify outliers and click compute, and it makes our box plot for us. One thing to be careful about when you're making these box plots in StatCrunch, if you select a variable, you select a data point, it'll put it in the, like a pink here. Anything that's pink is what you selected in StatCrunch. Sometimes you can drag over stuff and select it by accident. And these are not outliers in here. These are just values that I hit. If you do that, just click on the clear button and they go away. So anything that pink appears, you can get rid of it by just clicking that clear button. So there's our whiskers. And you can see, if I drag this over, we've got the range is 178. The Q, so it's a large range here. There's Q1, so I drag over it, 51. The IQR is 51 rather, so there's the IQR. Oop, I didn't select it. Let me go back and get that one. There it is. I'll click my control key. IQR 51. So we can see it's given us the same numbers, upper limit, lower limit. There's Q3 as 118.5, right? 118.5. There's our Q3. The average is there. Here's our median. So that's our box plot. So looking at this one, are there any outliers? Type in yes or no for this one. Do we have any outliers looking at the box plot? Anything looking? Yeah, yes, because we've got numbers out here. So beyond the whiskers, these are box plots. So 201, if I drag over them, you can see them, 203. And if I click on them, they pop up in the rows too, in the data set. There's our pink. So there's two outliers here. So again, they are, StatCrunch only does mild and above. So those are outliers, beyond the whiskers. Let me click that clear again and get that pink out of the way. So anything outside those whiskers are outliers. The Z-score. Z-score for 125 for the serum creatinine phosphatase. Z-scores. So for Z-scores, we go to the, get rid of these two, the stat tab, and for this one, we're going to go, and we don't do the Z-stat here, that's a whole nother test. So to get the score, we've actually got to click the data tab and we've got to compute an expression, because this is where StatCrunch has to know the formula to calculate the Z-score for us. So for that, we have to put in the expression. What we need to put in is that formula of the z-score, which is there on page 50. So it's the value minus the average divided by the standard deviation. So we can calculate this by hand, as well as have the software calculate it for us. So the z-score, the standard score, is going to be equal to the value minus the average divided by the standard deviation. Hold it up to my camera here. I think I've got it mirrored correctly, right? So that's right from page 50. So the z-score, we go back and we look at for 100. So we take our 100 minus the average, 98.28. So we're above the mean, so this should be a positive score. So we just put the average in our calculation. Then we divide by the standard deviation, which it calculated at 40.38. If you got your calculator, can you beat me to it? So 100 minus 98.28 divided by 40.38. So that's 1.72 divided by, Kristen's already got it, 0.0426. So we got the same value. So using the formula in the book, that's how we calculate the standard score. Again, positive number, we're above the average, right? So we've got our score of 100 is above the average, so we subtract 98.28 divided by the standard deviation, and we get 0.0426. Well, the software can do that too. It's just a little trickier. We're going to have to type in our expression. So we're going to type in this formula. And I made it easy for you. If you go back to the course shell to course resources, and in shared documents, I put a little Word doc on how to do that. So the guide to calculating z-scores, we can just copy and paste that into StatCrunch. StatCrunch costs like 20 bucks to buy. SPSS costs like 120 bucks. So this is how we save money. So we can take this formula and we're just going to put that into our stat expression. And then we got to make sure we have the right one. So I called it variable 2. So again, we're smart, the computer's not. We got to tell it what to do. And that's the formula from the book, right? So that's the value minus the mean, variable 2, divided by the standard deviation with brackets around it of variable 2. So then we click compute, and it'll calculate for every score. So if we go to 100, ta-da! So Kristen and I were right, we can calculate it. So we got the same answer. And gee, let's do one for each of the values. No, let's not do that. So the software can do that by taking that formula and we just put that into StatCrunch. And again, I have that sheet for you in course resources. You can just copy and paste it to get it to print out. And it prints those z-scores into your StatCrunch table for you. Again, to get rid of the pink, I'm going to click clear. So those are the standard scores. And 25, it calculated it for us. We can do it by hand, but 25 is negative 1.81. Again, negative because we're below the mean here. So that's one we got from the data from, and we could type this one in, and we had it typed in, or we did it from Word. And we can do one, if we do the mental health scores, let's go back to that one. I think I still have it open. Yes, I do. There's a mental health scores. We can do the same thing. If we just tap on the stat tab, summary stats, the column, right? We click on mental health. We can get all of those variables just clicking on them with the control key. IQR, the quartiles, and so forth. Then we click compute, and we've got all those values. Then we can go and do the box plot. Just click on the graph tab, box plot, mental health scores. We can just click on the median to make it more simple, click compute, and there's our box plot. Again, there's our quartiles, so it just plotted everything for us. Q1 is 25, right? Q3, 51, so it's all there. Type yes or no. Are there any outliers here for our mental health scores? Yes for outliers, no for no outliers for this one. Yeah, no, there's nothing beyond the whiskers. So there's no outliers in this data set, even though if we go back to the graphs, it kind of looks like there's some outliers, but they're not, because we did the IQRs, there's no outliers. These are still all within the range of what is within the range of the IQR. So we have some things that look low, they could be outliers, but not really. They're still attached to our data, and by mathematically, they're not outliers. So you can say something looks like it, but you have to calculate the IQR and prove that it's an outlier. We've already discussed a little bit about the cross-tabulation, and scatter plots you probably have done before, so this should not be too bad to finish up here tonight. We're almost done with everything for the assignments and the discussion threads. So again, this bivariate stats, we're going to look at two variables and we can correlate them, right? We can correlate a drug dose to cholesterol, smoking status, height and weight, and so forth. So it all depends on the variable, the level of measurement of the variable, right? So for cross-tabulation, we're going to do nominal level variables. So cross-tabulation is covered in chapter 4. And if you're into mathematics or Excel, it is the old pivot table, right? And our software can do it as well. So here's chapter 4. Cross-tabulation tables look like this, right? So this is page 61. And you can see we have cross-tabulation, right? We have counts, and this is all nominal level variables, right? Yes or no for a PPD diagnosis, marital status, not married, married, right? You're either married or not married, nominal level data. These are categories, and we just put the counts in here. So for example, we have 20 subjects, 20 patients that had a PPD diagnosis, 80 did not. We have 100 total in our sample. So most of our sample did not get a diagnosis. And the married group and non-married group. So we call this cross-tabulation because one is contingent upon the other. So in the single group, 8 out of the 20 got a diagnosis, and 12 of the married out of 20 got a diagnosis. So it looks like, you look at the first one, that a higher percentage of married folks are getting a diagnosis compared to those that are single. So one is contingent upon the other. So we call that a cross-tabulation table. And again, that's with nominal level variables. So you can have a 2x2 table, a 3x3 table, depending on the categories you have. You could have married, single, widowed. You could have more than one, more than 2 categories. But again, these are all nominal level variables. So again, they're just contingent upon one or the other. So for this table, also from the textbook, we have smokers. We have 20 smokers and 80 non-smokers, mixed between male and female, and also for non-smokers, right, split together. So we also have these things called marginal frequencies, where we're looking at the column and row percents for each ones, and those are all contingent upon each other, right? So just like we said here, we've got 10 men are smokers, 50% of all smokers are male, 20% of males are smokers, so they're all contingent on one another. So whenever we look at a crosstabs table, that's what we're looking at. We're looking at correlation between the two variables. So we can do these easily in StatCrunch. If we look at 12 patients in a study, we can jump in and just do some cross-tabulation. And again, in Excel, these are pivot tables. So whether we code the data with 1s or 2s, these are nominal level data, right? So 1 means they got a cold, 2 means they didn't. So we can just open up a new table here. So if we have the data, we can put them into our table. So in the first variable, we can call it the group that they were in, right? So we've got 6 people in the vitamin C group. And I can copy and paste that down. And we've got a placebo or a sugar group, so I can type in sugar. And again, this is all categories. And when I have the data set, each line in my data set is going to be a subject. So again, I'll clear that out. But so we've got 12 subjects total, 6 in the sugar group and 6 in the vitamin C group. So this is one variable, right? The group that they were in. And then the other group is their cold status. So in the vitamin C group, only 1 got a cold, right? The rest did not. So we have yes or no's. And again, we could code these 1s or 2s, but let's just use the categories for now and not numbers. And then the sugar group, 4 people got a cold. So I can just copy that down. And 2 people did not get a cold. So again, if I have the data set, every line is going to be a subject. So here we go. For this one, the dependent variable always goes in the rows. So the dependent variable is the outcome. Who can type in which is going to be our dependent variable here? Let me fix this one. Is it going to be the cold status or the group they were in? What's our outcome, our dependent variable going to be? Yeah, cold status, great. When we do our contingency table, we go to stat tab, and we're going to go to tables. So we did frequency already tonight. We'll do contingency, and we're going to select with data. Our row goes in with the dependent variable, the cold status. Our column variables, the independent variable, the group, and click our control key. We're going to get the row percent, the column percent of total. These 2 we're going to leave till next week, and we can click off the chi-square test because we're going to do that next week. So we'll just click that off. We're going to do the test next week, or actually in week 3. Click compute, and we've got our table. SPSS does it a lot better. So what we have to do is we have to pull this into Word. So we just take this table, click above it, copy it, and we'll open up Word and paste it there just to fix it. Make this a little bigger. Pull this over. And the goal is to make it look like, if you look in chapter 4 there, we want to make it look like this one. When in doubt, make it look like the textbook or a journal. So to do that in Word, we'll just pull this over. And I'll select over the top, right click. I'm going to insert some cells above, or rows above. Pull this one over. So here our yes or no is the cold status. And then here we can drag over these, right click and merge them. Another lesson in Word here, and just call this the group or the treatment or whatever they were in. So there's the group, right? And now we have these percentages. These are the row percentages. So it's percentage within the first one, the dependent variable. So this is percentage within cold status. Hit return. The next one is the column. So that's percentage within the group. And then the percentage of total. So we just have to do a little fixing in Word. And once we have that done, we can copy and paste that down. to the other 3. So just like we have in the textbook, we now have here. So again, we've got the dependent variable in the rows. So here we have the percent within the cold status. So here's the cold status is for the sugar group, right? We had 2 out of 7 were no, and we get the 0.2857 if I use my handy dandy calculator, right? So this is what each one's doing, and then this one's a column percent. So when you get that output from StatCrunch, you move that over, you just have to fix this in Word, and then you've got your table complete. Notice that I look at the total first, so I've got an N of 12. Does that make sense? I've got 12 in my data sheet, so that's for when we have the raw data. So that's what the contingency tables are telling us. It gives us an idea. Well, looks like most of the people in the vitamin C group, right, 71% didn't get a cold. So you would tell a patient, hey, if you take this treatment, 71% of the time you're not going to get a cold. So that's as difficult as contingencies tables gets. So this was the question. I think, I can't remember who had it. Was it Kristen or someone else? These are the things we add for the row percent and the column percent. Okay, so this is the row percent, right? The row they're in. This is the column percent for the group. So we make it look just like the textbook or a journal article. So again, that's just how you do it. We clicked on the tables, contingency, and we had the data depending on which we have. So we had the data because we typed it in. And then you clean it up in Word. For summary, sometimes you're just given the data, right? So if for summary data, we open another StatCrunch. So here we have a migraine study, and we have 49 subjects had a real surgery, 41 had a successful outcome of reduced migraines, 26 had the sham surgery, 15 had a successful outcome. So for summary data, we have to kind of reconstruct what we did in this table. So we have to kind of force the software to have a summary, like just the numbers. So the first one's going to be our dependent variable, and then the next 2 in StatCrunch would be the independent variable. So for this data, who can type in what would be the dependent variable here? The outcomes for the migraine reduction or the group they were in? What's going to be the dependent variable that we're going to put in that first column? Yeah, it's the outcome. A reduction in migraines. So yes or no, that one will go in the first column. Then we've got the groups, right? We've got the real surgery and the sham. So that's the independent variable, the group they're in, that's going to go in the next 2 columns. So then we just fill it in. So 49, 41. So 41 were a yes, successful outcome. 49 minus 41 is 8, right? So 8 out of 49 had unsuccessful, and the sham 15 were a yes. 26 subjects total. 26 minus 15 is 11, right? So that's how we do the summary data. So again, I don't have, what do we have in here? 49 and 20, 75 subjects. I don't have 75 lines in my data table, right? I just have the summary data. So now I can just go to the stat tab, the tables for contingency, and click with summary. And again, the row labels we said was going to be the outcome. And we're going to select the real and the sham to work on. And again, we'll just get these first 3. We'll leave these for next week, and we'll click off the chi-square test. We'll do that in week 3. And then there's our table. So if I haven't put you to sleep yet with statistics, we can just drag this right into Word, but I think we know what to do next, right? We'll do the percent within for each one. But if you look at the data, it's like those that got the real surgery, right? Most of them had a good outcome. But still, the sham, almost 30% of people had the sham got a reduction in migraines. So interesting report here. But most people had a good outcome with the real surgery. But even with those that had a bad outcome, right? So they didn't have a reduction. A lot of them had the sham surgery, about almost 60%. So really it's contingent upon one or the other. So when you meet with patients, you can tell them, well, you know, it looks like this really works, but there's some people that got the sham surgery that recovered fine. So some other factor may be affecting the outcome. So again, there's a way to do the contingency table with typing in the data and having the raw data and having the data typed in the summary fashion. So we can do the same thing. So for the discussion thread, you're going to do poverty and work status, and we can do poverty and marriage status. I think we have that one. We can go back and do that one on this data set. So for the discussion thread, you're going to do the poverty and work status. Can we do poverty and marriage status? Well, we can do that real easily. Again, click the stat tab, tables, contingency, and we do with data because we've got the whole data set in there, right? And again, for this one, what's going to be our outcome? What are we interested in? Their marriage status or their poverty level? What's going to be the dependent variable? Yeah, it's poverty. That's the outcome. We'll put that in the rows. And you know, their marriage status, that's just their category, right? Courtney got it too. Poverty is going to go in there. Again, we're going to do a row percent, column percent of total. Click off that chi-square for now. Click compute, and we've got our table. And again, we would drag this into Word, do the percent within, so we would modify these. But in interest of time, we won't do that. But it looks like for those below in the poverty level, boy, the single people didn't do too well. Of course, it looks like a lot of people are in poverty because the marriage people, let's see, more married people were above poverty, so they did better. One's contingent on the other. So based upon below or above poverty, marriage status seems to have some effect here. Interesting. So a lot of our sample in this one, there's a lot of impoverished people to begin with, so it's affecting our sample. So again, one's contingent upon the other. So the last thing tonight is correlation, and you've probably seen that before. You did scatter plots in math. So correlation is between, again, bivariate data, and we're looking at two quantitative variables. So again, it's going to be interval ratio data, and this is done with a scatter plot. So we put one variable on the x-axis and one variable on the y, and then we try to find a linear relationship. So a lot of things are linear. We give a patient a certain drug dose, and then we look at their change in cholesterol. So we hope to give, as the dose goes higher, the cholesterol should go lower. So a lot of bivariate data have linear relationships, and we've seen that. You probably remember from mathematics the equation of the line, right? So it can give you the direction and the magnitude of the relationship. So this is done in the last part of chapter 4. So for example, if x goes up and y goes up, that's a positive relationship. So you've probably seen these types of scatter plots before. If x increases and y decreases, that's a negative relationship. And we can predict values of y for values of x, and we'll do more of that in week 4 in this course. And if the data points are tightly packed together, it's a stronger relationship. If they're kind of scattered, it's a little bit weaker. And that's done by the R value, or what's called the correlation coefficient. So that's a Pearson's R. And if you look at chapter 4, you can calculate those, but I don't think we want to do that this late in the evening. But you can do that calculation when you look at the relationships. And that's on page 71. So there's the calculation of R, which I don't think we want to do tonight. But basically you take up each of the variables and you start summing them up. So you do this chart on page 72. You take the x's, right? You see how they deviate based upon what you predict of a straight line for each one. You add them up, square them. So it's quite a formula. So the R values vary. If you remember from math, right, varies from -1 to +1. The closer to 1 it is, the strongest. And so the sign indicates the direction, right? If it's negative, it's going to be a negative correlation, positive correlation. So they vary from -1 to +1. So again, you can rarely do this manually. We're going to make the software do this calculation for us. So again, 1 is a perfect positive relationship. Things about 0.5 or 0.7 are moderate. Anything below 0.5 is weak. And of course, 0 is no relationship, where you have no correlation between the two of them. So things can kind of get scattered. They're just a weaker correlation, but they still have a correlation. And when you look at the R value, you can take the R squared value. That's the proportion of variability. That tells us the proportion of one variable accounted for or explained by the second variable. So if your R value is about 0.6, then you square that. That tells you that 36% of the variation in weight is accounted for by height, or the variation in height. So R squared equals 0.36, right? So the remaining 64% is something else. Could be the phase of the moon, the amount of calories they take in, the exercise, their metabolism, and so forth. So the R value tells you the correlation, the R squared tells you the proportion of variability. And here's the last slide. So StatCrunch can do this pretty easily. So if you just type in your values, typically we put the dependent variable in the y-axis. So whether we type them in, or again, we could use them from Excel. So these are pulse rates before and after exercise. So of course they're going to go up, and we're going to see what the correlation is. This is why we pay people to input data for us on our grants. So you can type the data in. We've got 8 patients, right? 8 subjects. So we can graph it by clicking the graph tab. We've made it all the way down to scatter plot. Again, the X variable will do the before, because in the Y should go the outcome. Although sometimes the correlation is not as obvious to see which one is which, but they'll correlate the same anyway. And we click compute, and there's our correlation. So we've got one value out here. I mean, we could actually do a histogram or look at the outlier for this one if we did a box plot of the data. But we can also group it by, put the line in, by overlaying the polynomial order. The linear is 1, so it's going to do a best fit curve. And we can change the size if we like, but just click compute, and we've got the scatter plot. And then the R value we can get, click summary stats and go to correlation, select our 2 variables, and there's our R value, 0.61. So it's a moderate correlation. We've got some scatter, and that's our R value. So R squared would be, we just square that, is about 0.37. So 30% of the pulse rate is explained by their pulse rate before. The rest could be their, maybe athletes would be a little lower. Somebody not having some other heart issues might be a lot higher after. So about 37% is the correlation there, is the proportion of variability rather. And we can do the same thing. So if we do go back to our discussion question example, you can do a quick correlation. So Taylor, when we are entering the data into the spreadsheet, the dependent variable should be in the columns. So the dependent variable should go into the y-axis. And I'll do another example real quick to show you that. If we correlate this one, let's correlate mental health and the depression score. So again, we'll click the stat tab, and we can do the correlation pretty quickly. Summary stats correlation. So for that one, we're going to select the ones that we're coordinating. And here it's smart. It doesn't allow us to select nominal variables, right? The ID number we'll leave alone. That's not really exciting. We don't want that one. So there's our correlation. Oop, this one's going to be negative. So we should see the graph go down. Click on the graph, scatter plot. So the X. So this one, That's going to correlate both of them, but probably we want to see what effect the mental health score has on depression. So we can put the mental health score there and the depression score and see what we get. We can always flip it. Yeah, this is a negative correlation. And let me go back. I can put the linear fit in there. Overlay to 1. So that's a best fit linear curve, and click compute. So this one's a negative correlation. Make that a little larger. Mental health score goes up, the depression score goes down, which is good, right? Because this depression would hopefully go down with the better mental health score. And it's a moderate 0.42. And again, we just square that to get the proportion of variability. And it's about 18.5%. So there's a lot more factors. 18.5% of the variability in the mental health score is accounted for by the depression score. So there's probably other things like age or income, marriage, status, and so forth. That's it. Okay, so we've done it. Let's look at what's left. So we did a lot of examples tonight. Thanks everyone for hanging in there. This is the worst part of stats is descriptive statistics. So in StatCrunch resources, you've got the StatCrunch from there, the instructional videos. It's my YouTube channel. So you'll probably be sick of me by the end of this course, but I've got quick links there if you forget what we did. Also there's some more videos about things if you want to click on the My Stat Lab. We've got the discussion questions we went through, so we can all do those now, and people are posting up their answers to those. And again, once you post your thread, you can practice here. So start with the discussion threads, practice your StatCrunch there. Once you post, you can see everybody's answers, and I'll leave you feedback there, and others can as well. There's the video link if you get lost. The assignment is here. And I think we've gone through everything in the assignment. Great. Okay, good work, everybody. Thanks for hanging in there. Again, this will record, and you've got download the slides, so you can scan through the stuff that you missed or that you want to catch up on. You don't have to watch the whole recording if you don't want to. But I will go ahead and pause the recording there.